Welcome everybody to our notes here for 3.3. We're going to talk about sine and cosine function values. This is a good one for you. Make sure that you like and subscribe so you can get more good content from me. Actually, there's another channel that you really should subscribe to. It is Cranky. It is Cranky Calculus. Just search that up. Make sure that when you watch the videos, you watch the whole thing. Do not mess up my algorithm. Watch the whole thing. So you're probably not ready yet for this, but go ahead and subscribe so that when you do take calculus, you're ready to go. All right, so let's talk about how to find values for sine and cosine functions here. This is going to be a bit of a reminder for coordinates of a point on a circle centered at the origin here. We can find out our sine and our x and our y values by doing this. So x is equal to r cosine of x. Okay, so y'all need to know that. And we need to know that y is equal to r sine of theta. And we can know that because from our previous lesson, we talked about how cosine of theta is equal to x over r and sine of theta is equal to y over r. And we can all play that on over here, okay? So our coordinate points that we have here, if we have an r, every point on the circle will be r cosine theta, comma, r sine theta. So this is going to pertain to the x's right here. This will pertain to the y's. Now, what if our circle had a radius of 1? Then the x value would be only cosine, and the y value would be only sine. Okay, so let's take that, and let's go ahead and move on to this example down here. So I'm going to give you this circle right here. And what's the radius of this circle? 1. How do we know it was 1? 1 comma 0. Obviously, that's on the edge of the circle there, so we have a radius of 1. So this is going to be our r equals 1. And now let's go ahead and look at these values here. What is cosine of 0? So when we're talking about this 0, this is our theta value. So this is when theta is equal to 0. So on our unit circle, remember, we always open up from the standard positions here, and we always open up into this direction over here. So this is going to represent theta. So when theta is equal to 0, we're not opened up at all. Cosine is going to be which coordinate, x or y? Cosine is going to be x with a radius of 1. So what's the x value when theta is equal to 0?
1.
So the x value is 1. So cosine of 0 is equal to 1. Sine of 0, this is when theta is equal to 0. Sine represents which coordinate?
Y.
So sine is going to be y. I forgot to put the little x over here. Forgive me. So what's the y coordinate when theta is equal to 0? 0. So in your formula quizzes, I can pull out a card that says sine of 0. You need to know what the answer is. It is 0. I can pull out a card that says cosine of 0. You should know what the answer is. It's 1. Okay, let's go ahead and work our way up here. So what about cosine of pi over 2? What is theta equal for this one? Where is that located? We're opening up here. Do you remember from last lesson we talked about how much we open up? If we open up halfway, that's pi. If we open up the whole way, that's 2 pi. So what if we open up halfway from halfway? You get pi over 2. So this is going to be pi over 2 up here. Since that's pi over 2, I'm looking at cosine, which again is the x coordinate. So what's this answer? 0. What about sine? That's going to be the y coordinate. And what's that answer? 1. Do we see where these values are coming from?
Yes.
All right. Thank you for lying on video. Appreciate it. Okay, the next one right here, cosine of pi. This is when we open up half of the circle. So we're going to open up all the way to over here. This is in the pi direction. So we're looking for x's at pi. What's that value? -1. Very good. Here are the y's at pi. What do we get for that? 0. Where in the world is my 3 pi over 2 located? Which coordinate point? Is it going to be P, Q, R, or S?
S.
It's going to be s. So down here is going to be my 3 pi over 2. And so what's that value? If this is going to be x's. This is 0. And then what about the y's? -1. Memorize those 8 things. Or, do you have to memorize it? Could you figure it out if you had to?
Yeah.
Probably. So let's flip it on over. So by the way, those are all my quadrantals. Talked about that before. Quadrantals are the ones that lie on the x-axis or y-axis, above the origin, below the origin, to the right or left of the origin. So now, in these notes, they kind of give us these points, which is kind of nice. And we're going to go ahead and make a table from here and figure out what some of these values are. So at P, we're saying that that angle measure right here is pi over 6. So this right here is, I'll zoom in so you can see it better. This right here is pi over 6. Okay, I kind of want to explain how these coordinate points came about. This is a unit circle, which means that the r is equal to 1. This tells me that QRO and PSO are equilateral triangles that are inside the circle. Okay, so this is an equilateral triangle. What does that mean?
60 degrees.
Okay, first off, we don't do degrees around here. We don't do no degrees. We can use degrees to reference, but we don't talk about degrees. But it means that every single side is equal and every single angle is equal. Okay, so right here, if this is pi over 6 over here, how much is it down here in quadrant 4? Also pi over 6. Okay, so that makes this angle right here how much? Not pi over 6. If this entire angle right here is, it's 2 pi over 6. We can say that as pi over 3. Yeah, did you use AI for that or no?
That was really mean. That was really mean.
They don't know who you are. So this right here is going to be pi over 3 as a measure. This right here is also pi over 3 as a measure.
Oh, isn't this like the first lesson that we did?
Kind of, sort of. So now, if this is 1 right here, how the heck did we get this p-value to have a height of 1/2? The radius is 1. How much is it from P to S?
Oh, also 1.
Also 1, so we cut that in half and we get
1/2.
1/2. Use Pythag to figure out this coordinate as well. Got it? Okay, so, by the way, where is point Q? If point P is pi over 6, we talked about this last class, what is point Q? 5 pi over 6. What's the coordinate point there at Q now? So use P, we're going to mirror it over. What changes, the x value or the y value from P? The x value changes, but the y value is going to remain the same. So this is going to be negative root 3 over 2, comma, 1/2. From point P to R, angle value is going to be similar where it's over 6, but what changes, the x coordinate, the y coordinate, or all of the above? All of the above. We're going to quadrant 3, so now we have, for R, we're going to have the points negative root 3 over 2, comma, negative 1 over 2. Okay? And what does that R measure? Who remembers from last time?
7 pi over 6.
7 pi over 6. From S, from P to S, what's the only coordinate that changes?
Y.
The y changes, so the x will remain the same from P, and the y becomes
Negative 1/2.
-1/2. And what is that value at S? That
11 pi over 6.
So now from here you can use this chart to help you out with this. For cosine of 11 pi over 6, again, cosine is x or y? X. So look at the x value at 11 pi over 6. What do we get?
Root 3 over 2.
Root 3 over 2. Yeah? Yeah. What about sine of 7 pi over 6? It's going to be 7 pi over 6. It's going to be over here, so we're looking at the y coordinate. Negative 1/2. All right, so let's be careful on this one. Sine of negative pi over 6. That is not written down on my chart, but I can make it on the chart. Negative pi over 6 means instead of opening up counterclockwise, I'm actually going to open up clockwise. So starting from here, going open to pi over 6 brings me to which letter? P, S, R, or Q? Brings us to S. So this is actually equivalent to sine of 11 pi over 6. They're mathematically equivalent. And so this is going to be, again, the y value. So this answer is negative 1/2.
I have a question.
Yes.
Could we just say that if it was negative pi over 6, could we just just make it a negative?
Make what negative? The answer negative?
The sign, yeah.
No, that property, sine, by the way, is an odd function. You don't know that yet. So what property do odd functions have? So actually inside the argument here means that we can rewrite this as negative sine of pi over 6. That makes this an odd function, which I'm telling you is true. And so this would just be sine of pi over 6, which is 1/2, and we can make it negative. That works for sine because sine's odd. It's easiest for right now if you just go through and use this chart, or you do what I'm going to do later, which I think simplifies everything that we've done. Cosine is an even function. So if we had cosine of negative pi over 6, what does an even function mean? That the negative turns into a positive function. So if you notice, cosine of pi over 6 would bring us over here, which would give us an answer of root 3 over 2, which is actually the same thing as cosine of pi over 6, which is also root 3 over 2. This is great. We're really moving forward. Good job, class. Good job, twin. All right, so we good here in the pi over 6s? Okay. If you notice, all the pi over 6s, they have the same x coordinates, same y coordinates. The only thing that changes are the negative and positive signs. Okay, I call this the pi over 6 family. All right, let's wave goodbye to the pi over 6 family, and let's go meet the pi over 4 family. All right, it's another good solid family. Good people, I think. So, unit circle again. R is 1. And now our P, R, Q, R, S, and so our P, Q, R, and S have all shifted so that we represent this by pi over 4. So now, how in the world did we get the root 2 over 2, comma root 2 over 2? So, this is an isosceles triangle. This is 1 right here. This is 1 right here. Isosceles triangle means that the x's and the y's are going to be the same for this situation. Okay, so x is equal to y. So from that, we can use the Pythagorean theorem. Bam! That's how you get that x is equal to plus and minus 1 over root 2. We just happen to rationalize it, so it becomes root 2 over 2. Okay, so pi over 4s give us the root 2s over 2s with this very special triangle where we have the pi over 4. Okay, somebody works for pi over 4, mind you. Okay. Maybe my explanation wasn't very good. I'm going to do better than that. Because I'm on video, I should do better. So if this is pi over 4 right here, how much is this right here? Also pi over 4. If you add those together, you get what?
2 pi over 4.
2 pi over 4, which is pi over 2, which forms a right angle. So this right here forms a whole right angle. If this is 1 right here, and this is 1 right here, then you would get the height of this right here to be root 2. This whole from P to S is root 2. Therefore, from this line up to P is going to give us 1/2 root 2. Is that maybe an easier way to understand why the heck this happens? It's probably easier. And then x's and y's will be the same for pi over 4. Because we can do the exact same thing going from P to Q. The exact same thing. Right triangle, same thing. That whole from P to Q is root 2. Cut it in half. You'll get root 2 over 2. All right, cool. So, fam, let's go ahead and go through this. So, if P is pi over 4, what is Q?
2 pi over 4.
Try again. 3 pi over 4. What's the coordinate points there, then? Which one changes, the x or the y? So, negative root 2 over 2, comma, root 2 over 2. R is on the other side, so everything's going to change. By the way, what's the angle measure for R? 5 pi over 4, and that's going to give us negative root 2 over 2, comma, root 2 over 2. I was just making sure that my studio audience here is paying attention. It should be negative and negative. And then what's S become? Which gives us coordinate points of? Can we answer these questions over here? Sine of 5 pi over 4. Sine is Y? Negative root 2 over 2. Cosine of 7 pi over 4. It's going to be the it's positive. It's X right there. For this angle measure of negative 3 pi over 4, what letter is that going to put me at? It's going to put us at Q. Q? Q? I'm not believing you.
It'll be R.
It's me what?
R.
Wait, a bunch of pirates in here? Ah, this one's at R. So this is equivalent to sine of 5 pi over 4. Again, if we open up 3 pi over 4, we're going to get to right here, which is where R is. And this answer is?
Negative root.
Okay. A couple of things here. I'm going to keep this here just for a quick little second here. I hope you're noticing things. Is that in the first quadrant, everything's positive. In the second quadrant, what's the only positive value that we have? Sine. So it's Y, which is sine. So sine's positive over here. In quadrant 4, so I'm going to put sine theta positive, plus sine. In quadrant 4, what's the only one that's positive? Cosine theta is positive. Quadrant 3, both sine and cosine are negative. What's the third trig function that we haven't talked about quite yet? It's going to be tangent. Okay, how do we find tangent? Sine over cosine. So if we do sine over cosine, tangent of theta is going to be positive over here.
All students take calculus.
Have you heard that before?
Yep.
They don't all take calculus. Please, not all students need to take calculus. It's not for everybody. Stop signing up for my class because it's my class. I'm sick of it. You know how many kids have to kick out every year? Staying in the video, by the way. Let's move on. All right, so we talked about the pi over 6 family, the pi over 4 family, and now we're on our last family here. Pi over 3 family. Pi over 3 family is going to form equilateral triangles. Instead of being left and right, it's going to go up and down. That's how we get this coordinate points of 1/2 comma root 3 over 2. Are we cool with those coordinate points being where they are? Do we explain why they are what they are?
No.
We cool? Yeah. Cool. So if P is pi over 3, just across the way to Q, we're going to get 2 pi over 3. And the coordinate point, the only thing that's going to change here for the coordinate point is the x changes to negative 1/2 root 3 over 2. What does R become?
4 pi over 3.
And we get negatives on the x's and the y's. Last but not least, S. 5 pi over 3 is the angle measure, and then the coordinates are positive x, negative y. Okay, and before I actually move on to answer these questions over here, a lot of people will make you memorize this circle. I'm not going to make you memorize this circle. Can you find out any of these values if you had to? You can easily draw this stuff up. There's a way that's a little bit simpler, but if you want to understand this and memorize this, that's on you. I will go over very shortly on a blank sheet of paper how I do this and how I taught my students in years past, and they seem to be better at it. They're faster at unit circle than everybody else. So I'll show you that way. It's a sneak preview. Stay tuned. It's a long video. 20 minutes right now? Holy cow. You know what, though? It's needed. Sometimes the long videos are needed.
Yeah, because if it wasn't for a
Then y'all have no clue what's going on. So, hey, what's sine of 2 pi over 3? Sine, by the way, is which letter? Q? Sure. I mean, you're not right. Sure. What's the y value of Q? What is it? What's this cosine one?
X.
That's going to be x, and we're at what point now? We're at r.
Negative 1/2.
Okay, and then for this one right here. Oh, where is this? Where is this negative pi over 4? This is going to be at s. So this is equivalent to cosine of 5 pi over 3, which is equal to...
Negative 3.
Sorry, whoa, what am I doing? Whoa. I was just seeing if the studio audience was paying attention. Good job, you're still there. Yeah, why does it say pi over 4? You know what? Who made these notes? Oh, I did? Okay. Hold on. Stolen. I stole these notes. Let's, hold on here. Hold on. We're editing nothing out. This is raw material here. Let's change this completely up to a different question. Let's change this to
Why don't we just do pi over 3?
cosine of negative pi over 3.
Oh,
It fits the notes better. Sorry, I was just in the groove with the pi over 3 family. So, what does this become?
1/2.
Cosine of 5 pi over 3, which is 1/2. We got it eventually. Okay. And the reason that I'm okay with introducing questions like this with these radius of 1 is because you'll get asked questions like this on your tests, and that will get kind of wordy, and it's good for you to see this and how we came up with some of these values. Okay, like if you look on your worksheet there, we're not going to get the worksheet quite yet. But if you look at your worksheet, you'll see quite a few pictures that look like one of these 3 pictures that we just did. I think the only thing that's different is the radius, and y'all just need to be able to pick out whatever points we need to pick out. And y'all need to be able to use symmetry to go from point P to point R and vice versa and stuff like that. Okay, so y'all want to see how to really do this?
Yeah.
All right. Here's the good stuff. This is what I do.
On the back of ours.
What's that? This might, because this is... I might snip this and put this on the good channel. I don't know yet. Depends how well this video goes. We'll see. Okay, so before I get to you to memorizing all of the... Actually, you know what? I'm going to help you out with the first quadrant, include the quadrantals for the unit circle. Memorizing these values. Okay? This is what you're going to do. I'll make a little bit of chart here. I'm going to start with sine theta. Make a little chart here. Just kind of try to match up what I got. And we're going to go cosine theta. Leave some room down here for the next one. And we're going to go all radians. We're going to go in order. We're going to go to 0. We're going to go, what's after 0?
1.
Okay. And within our unit circle, the next radian value that we care about is
Pi over
6. Then, very good class, studio audience, not very on it right now.
Oh, and then pi over 3.
Pi over 4, then pi over 3, and let's run this out with the last quadrantal of pi over 2. Okay, I'm going to start with sine and cosine, then I'll work my way to tangent. What I'm going to do here is I'm going to kind of sort of cut these in halvesies. Okay. So that I'm gonna show my work on the upper one, and I'll have the final answer in the bottom one. That way y'all can kind of see where everything comes from here. Okay, so I'm gonna show my work right here. So for all of these all go into a pattern. Okay, so these all go into root 0 over 2. These are all over 2's, by the way. Sine is an increasing function, so this is going to be root 1 over 2, this is root 2 over 2, this is root 3 over 2, this is root 4 over 2. Sine is an increasing function. So we go from 0 to 1 to 2 to 3 to 4. Sine increases, sorry, it's an increasing function from 0 to pi over 2. The x's, or sorry, the y's get larger. Makes sense. The y's get larger as you go around the unit circle. Okay? For cosine, what do the x's do? They get smaller. So this is a decreasing function. So we're good. Everything over 2, everything's square root of something over 2. So I'm going to put all these over 2. So this is going to be root 4, root 3, root 2, root 1, root 0. This is the pattern they all go in. Let's clean this up a little bit. So for sine, what's sine of 0? Simplified, this is, very good class, 0. Simplifying this right here, in green here, we got 1/2. Simplify this one, you can't. It's just going to remain as root 2 over 2. This one right here remains as root 3 over 2. What's root 4 over 2 equal? So 2 over 2, which is 1. Let's do cosine now. It should be the exact same thing, exact same values, but in descending order. A little bit easier to memorize, I think, right? I think it was a little easier. Okay. So what's our last thing that we actually can add on here that we haven't talked about yet? Tangent. How do you find tangent? That's x over y, which is sine over cosine. Okay, so let's do the first thing. What's 0 over... Let's actually, I'll do the same thing where I have like work and then final answer. So we're going to get 0 over 1. Then we're going to get 1/2 over root 3 over 2. Then we're going to get root 2 over 2 over root 2 over 2. Root 3 over 2 over 1 over 2. And then 1 over 0. Let's green it up. What's 0 over 1? 0. These over 2's cancel out, leaving you with 1 over root 3. I like that answer. Some people like to rationalize it as root 3 over 3. Either one's totally fine, widely accepted in the world of trigonometry. The next one's going to be root 2 over 2 divided by root 2 over 2 is?
1.
Yeah, good job. 1. Root 3. And you can't divide by 0, so that would be undefined. Can you memorize that? Okay. So if I were to ask you, what is cosine of pi over 3? What's the answer? 1/2. What's sine of pi over 6? Also 1/2. What's tangent of pi over 4? 1. This is quadrant 1. Got it? What about the other quadrants? We can use the exact same table. Don't have to redo anything. We talked about this a little bit earlier. Quadrant 1. All of these functions are positive. All are positive. Quadrant 2. Sine is positive. Quadrant 3. Tangent is positive. Quadrant 4. Did I mess up? Yes. I have a boo-boo here on this video. This should be y over x. The sine over cosine part is correct. So my bad on that on the video. Life happens. Okay, so now with this, can I find out what sine of 3 pi over 4 is from this? So what I'm going to do here is, we're in the pi over 4 family. So we're here. We're at sine of pi over 4. And what quadrant am I in? 2. Sine is positive, so the answer is? Positive root 2 over 2. If I do cosine of 7 pi over 6, I need to know that value. I'm in the pi over 6 family for cosine. I'm in quadrant 3, so cosine is negative, so the answer is? Negative root 3.
Oh, looking at the wrong one.
Yep, root 3 over 2. We low-key get it? Low-key get it.
I don't get that too, what you did there.
This right here?
Yeah, I don't get that.
Okay. So all the x's and y's are positive here, right? In S, we have negative x's and y. So that's why sine's still positive, cosine is not.
Okay.
Oh, you're fine. You're fine. You know, let's. Oh, I forgot the negative y there. That's negative x, negative y. And this is going to be positive x, negative y. So that's why that's algebra right there. Does this help y'all? Okay.